17, we're talking about net versus total area. So net area is all the increases and decreases in area as you go from left to right. Some areas are positive, as in accumulations, and some are negative, as in decumulations or reductions. The net area is how much area you have left after you've accounted for all that. The total area is the physical area that's present within a bounded region, whether it's technically a positive region or a negative region. All right. So absolute values come into play here, and it's pretty nifty. So we'll kind of see that as we go. But when you're looking for, in the case of number one, for example, the net area, it's really as simple as saying the integral over the interval of negative 2 to 2, that's our a and b value, of y, which is x cubed minus 4x dx. Right? So for that, you can put it in your calculator. You can evaluate it by hand if you like. It's really up to you. I have a general rule of thumb when it comes to application questions where we're applying a concept, that if you want to do that on the calculator, you're fine. It's only the ones where I specifically ask you to do something analytically that's when you'd have to do it by hand. So, if you're taking a test and it doesn't say the words solve analytically, then you're free to do it any way you want. Now this one, you can see here, it says it, so we have to do it by hand. But just bear that idea in mind. All right. So the antiderivative, 1/4 x to the fourth minus 2x squared over the interval of negative 2 to 2. Now, I don't need you to show me any rote computations. So once you've performed any substitutions, however you want to do it from there is your business. So 1/4 times 2 to the fourth minus 2 times 2 squared minus parentheses 1/4 negative 2 to the fourth minus 2 times negative 2 squared. All right, so from here, you can, like I said, you could solve it any way you like. All right, so if it means putting it in a calculator or doing it by hand, that's up to you. What some people will do is they'll do all this work just to get the credit, and then Math 9 to get the answer. It's really up to you at that point, because you've shown me everything I need in terms of the analysis in order to get the appropriate credit. So, and oftentimes I won't even ask you to give me an answer. Sometimes I just want the integral or a particular aspect of the computation. So we get a result of 0 here. All right, so let's take a look at the graph and see why that might have been the case. Okay, so I'm going to type in the original function, x to the third. Now you can find the roots and all that stuff if you want, but it's not an algebra course, so feel free to use technology appropriately. So you see here we have what appears to be equal parts of the graph above and below the axis on the interval of negative 2 to 2. So that's a pretty good justification for why we would expect the net area to be equal to 0. So the total area is how much physical area, how much physical space is occupied by these two pieces. All right? Since it's symmetrical, we're dealing with an odd function. Since it's symmetrical, all I would really need to do is figure out the area for one piece and then double it. All right, so I'll go from negative 2 to 0 because that gives me the positive piece, the part that's above the x-axis. The act of taking the antiderivative is the same, so we're good there. Could even steal a lot of this work. and just pop out the 2's and replace them with zeros. Okay, so that'll give me really half of what I want, but it'll give me something. All right, so these go to 0, so irrelevant. Negative, I got the 1/4 times a 16 minus 2 times a 4. So this is negative 4 minus 8. So 4 minus 8 is negative 4. Negative negative 4 is going to be equal to a 4. So now it's just a matter of doubling it, because I got half of what I want. So I take that and double it, and we're good to go. All right. Now, a nifty little trick, especially if you don't have to do something analytically, is instead of figuring out the area of just one part and doubling it and all that stuff, is we can change the function itself so that all parts are above the axis, and then use a definite integral over the entire region. All right, so let me just show you real quick. If we take the absolute value, so alpha window option 1 of my original function, all right, so alpha trace y1, I'm going to make the second equation bold, so it's, so it pops, so it stands out. I'm going to hit graph. You'll see that it traces directly over the parts that are above the axis. Oh, sorry, traced the wrong thing. It traces directly over the parts that are above the axis, this part and this part, but it reflects the parts that are below. So the parts that are below the x-axis, it reflects those parts so that they're above the x-axis. So then what I can do is integrate over the interval of -2 to 2, and then it'll give me the sum total. All right, so we could do that in the calculator, we could do it by hand, but it's, once you get absolute values involved, it's much easier to do it in the calculator. So second trace, option 7, it asks you for the lower bound, -2, just type it in, enter. Upper bound, 2, hit enter. All right, so that's what the original function's integral would be. I want to look at my new function. I can clear that out, or I can, can't really clear it out, can I? y2 is referring to y1. Okay, well, I wish I didn't do that. Yeah, there's no undo button on these calculators. I'll just type it in again. So, x cubed minus 4x. Yeah, I should have just hit enter on the equal sign to turn off y1, but I zigged when I should have zagged. So that's the absolute function. So let's second trace option 7, -2, enter, +2, enter, and you see that gives you the 8. All right, so that's pretty cool. All right, so number 2, it's another one of those ideas where as long as you know what's going on in terms of the graph, then you're in good shape. So let's take a look at the sine function. Ordinary sine function looks like this. Covered this a couple of videos ago. Here's pi over 2. We got a pi over here. This is 3 pi over 2. We know and this is just based off memory, but memory's considered a good thing. All right, so under that first arch, we know that we have an area of 2. All right, that's from experience. All right, each half of that arc, or arch, or whatever the right word is going to have an area of 1. So each little piece amounts to an area of 1, but some parts are below the axis and some parts are above the axis. So when I want to find the net area, I could integrate over the interval of 0 to 3 pi over 2 my function sine of x dx, which would give me negative cosine of x over the interval of 0 to 3 pi over 2. And then I could make my substitutions. All right, and so if I do that, I get negative cosine of 3 pi over 2 minus negative cosine of 0. So cosine of 3 pi over 2 gives you a 0. So negative 1. Cosine of 0 is 1. Negated is negative 1. Negated again gives you a positive 1. So from 0 to 3 pi over 2, we should have a positive 1. Well, if I take 1, another 1 that gives me 2, knock off 1, by the time I get from 0 to 3 pi over 2, I will have gained 2 and then lost 1 for a net of 1. Right? Now for the total, what I would have to do, if I'm doing it analytically, is account for either symmetry or, just add up all the individual pieces. If I want the total area, really what I'm doing is I'm taking the area going from 0 to pi over 2 of sine of x dx, and because I have 3 equivalent areas, I could just take that and multiply it by 3. All right, so a lot of the follow-up work is going to be the same. So negative cosine of pi over 2 minus negative cosine of 0. So that's going to give me a 1, but then I would multiply that by 3. All right. Or you just look at the picture and say, well, I have 3 equivalent regions all having an area of 1. So 3 times 1 is 3 and call it a day. All right. Or you can use the absolute value trick in the calculator and do it that way. All right. Now there's another way of finding the result of integrals using the calculator. So let me just show you that real quick. Let's say you have the sine of x as y1. You studied it, you studied its graph, everything looks pretty good, but you want to find its integral, but you don't want to use the graphing feature. You can go to Math 9. In this case, we were talking about 3 multiplied by that, so let me just tuck that in there. Second delete allows you to insert something. So 0 to pi over 2. Now instead of typing in sine of x, which you could do easily, but let's say it's a really complicated equation that you just typed in to y equals into the y1, and you're like, I don't want to type that in again. What you could do is you just type in alpha trace y1, just bring the y1 here, and the calculator will know what to do with it. All right, so you can kind of work it that way. All right.